Hi, thank you for the intro. Hi, I'm Kaz. I'm a developer advocate based in Tokyo, and I'm from Google Cloud team. So I have been, talking about in the public events, talking about the Google Cloud AI tools, such as the Cloud AutoML, which I'll be talking about from now. So in next 30 minutes, I'd like to talk about three topics. The first, I'd like to talk about Cloud AutoML Vision, especially how you can use it for the Edge AI use cases. And also, I'd like to show what is HTTP and Coral and how it can be used with the AutoML. The lastly, if I could have some the remaining time, I could also introduce about AutoML tables. So AutoML Vision and AutoML Vision Edge, which is about automated HTML development. So as you have seen, you have been hearing all about TensorFlow Lite or TensorFlow. You may notice that it's not that so easy stuff because you have to understand the basics of the machine learning, starting from the data preprocessing, how you can design your TensorFlow model with some the popular network design, like design such as the mobile net or maybe fully connected neural network, etc. And also you have to spend much time on the hyperparameter tuning. Hyperparameters means the things like the how many layers you should have in the neural network design, or what kind of the activation function you should use. Those are the all so-called hyperparameters, and there's no mathematical theory to control or optimize that. So everybody is doing these things like the random search, grid search, or Gaussian process-based search. Means that you have to have many triads for finding the best hyperparameters. And also you have to do some evaluation of the models. And that's not the end of the story. You have to hire another bunch of the people, so-called ML ops people or the infrastructure engineers who understands about the both machine learning and also the infrastructure to deploy your model for the production use cases. And also you have to build the whole machine learning pipeline because if it's the production system, you have to keep updating the model periodically. It's going to be like every week or every month or every quarter or every 5 minutes. It depends on the business requirements, but you have to retrain the model based on the business requirements. So it's so easy to use the prepared models such as the vision or the object detections provided by the ML kit. But if you decided to use the TensorFlow or TensorFlow Lite or to customize or design your own models, the complexity and the time and also for the development cost increases rapidly. You have to spend like $100 or maybe $200,000 just for POC, and you have to wait for a couple of months. So that has been the biggest challenges for any machine learning production projects. So we are trying to solve that problem by introducing the Cloud AutoML. That technology tries to automate a major part of the complex processes of the machine learning. The first product from the AutoML the suite is called AutoML Vision, that allows you to use the sophisticated user interfaces on the Google Cloud so that you can easily upload your training data, training images on the cloud, and just press the training button. So you just have to wait for like 12 hours or 24 hours until the cloud services train the model for you. So you can cut down the major part of the cost and time for customizing the models. And but still, because this is a machine learning, so downside is that you have to prepare for all the training data yet. So for example, if you are doing the image recognition or object detection, you still have to collect all the training data. For example, for each class, it would require like 1,000 images. So if you have multiple classes, you have to collect like 10,000, 20,000, or maybe tens of thousands of images for training data. That is not shortcut. But once you have uploaded those training images to the AutoML Vision user interface, then you can just press your training button and wait and see and how the cloud service can generate the customized model for you. And also the AutoML Vision provides the deployment and also serving service for you. So you don't have to hire a bunch of another ML ops people or DevOps people to build your own Kubernetes cluster or scalable cluster or the virtual machine instances for deploying your models. Instead, you can just press deploy button so that AutoML Vision will create a new GK cluster inside it. You don't have to care about that. And based on the workload you're getting for the deployment or serving infrastructure, you can easily add new instances just by changing the configuration of the system. Let's take a look at some interesting use cases of the AutoML Vision. This is a ramen use case as one of the funny the demonstration. There is one data scientist in Tokyo who has been collecting about 50,000 of the different images of the ramen bowls, all from the same ramen franchise called Ramen Jiro. Ramen Jiro is a very popular ramen franchise in Tokyo. They have 41 different branches in Tokyo, and they are very popular. And if you take a look at those 3 different bowls, you can find they're sharing the same bowls and same design of the tables, red table. But the ramen bowls are made at the different Ramen Jiro branches. But when the data scientist put all of those 50,000 images to the AutoML Vision and press the training button, then amazingly, this cloud service was able to produce a TensorFlow model that provides the 95% accuracy on recognizing the Ramen Jiro branches. So if you specify one of these images, the model can tell what is the branch, Ramen Jiro branch, who created this particular ramen bowl. So as you can see, all of the images shares the same ramen bowl as well as the table colors. So the only difference or features the model can see is how they can serve the vegetables or the meats, how they cut those meat and the toppings. So that's the only features the model can use. But still, automatically, Cloud AutoML Vision was able to extract those features without any help from the human data scientist and get the 95% accuracy. This is an amazing use case. And there's another more serious business use cases by Mercari. Mercari is one of the most popular selling app in Japan and also the United States. And they has been evaluating the AutoML Vision, whether it can be used for recognizing the brand names for each product the people are selling. So if you are uploading any bags from Chanel or Gucci or any other brands, it tries to suggest what is the brand name, so what is the category of those products. And they got the 90% accuracy without any major help from the data scientist. Well, let's take a look at the video, how the development process would flow with the Cloud AutoML Vision. So as I mentioned, all you have to do is to upload all the thousands or tens of thousands of the training images to the Google Cloud and press the training button. So at first, maybe you can just use this very simple folder structure for collecting those training image, and you can compress everything into a zip file and upload it to the Cloud AI, the AutoML Vision user interface like this. Then you can confirm if the uploaded images looks great, and you can also count the number of each class. In this case, we have used the 58,000 images for recognizing the outfits, the wears, fashion items, and press the training button, and you can just wait for like 12 hours or maybe up to 24 hours. Then after that, you would get a report from the service. Looks like you can get like a 95% accuracy on recognizing those images. Particularly, if you take a look at the suit, you can recognize the suit at the 97% accuracy. So looks like the model looks good. So you can download the model as a TensorFlow Lite model with the .TFlite file format. This particular file has the about 7 megabytes as its size, so it's pretty small. And then you can buy some the cheap hardware, edge hardware, or like the Raspberry Pi with the AI processor Coral, which I'll be talking about later. By adding this AI processor, you can get like a 20 or 30 times faster image recognition time. But the hardware cost is less than like $200. It's super cheap. Lastly, you can go to the Coral website and download SDK of the AI processor HTPU and install it. It shouldn't take over 15 minutes. And also, you can use the Python SDK to pass the image file to the AI processor with the TensorFlow Lite model provided by the AutoML and get the recognition result instantly. You can try that. So for using the AI processor and also the TensorFlow Lite model from the AutoML, you don't have to have the serious cutting edge the AI expertise. You can just pass the images and the model to the API, so that you can instantly build this kind of the self-checkout system by yourself. The hardware cost is less than $200 or maybe $300. The cost of the AutoML training was less than $100, like $50 or maybe $100. Without any serious machine learning expertise. You have to have the basics of the machine learning, the knowledges, like what is the false negatives for or false positive, what's the ROC curve or things like that. But you don't have to be the senior data scientist. So that's the idea of the Cloud Edge. So AutoML Vision Edge. And I'd like to talk about the second topics, which is about the AutoML Edge TPU, the Edge TPU. As you can see, we see the Edge ML or Edge AI explosion. So until a few years ago, everybody, data scientists, are trying to do all the training and the prediction of the machine learning model at the cloud side, or maybe with the powerful GPU machine, desktop GPU machine. But right now, the Google is focusing on bringing everything, especially the prediction, recognition part, to the edge devices, like having the smartphones or the watches, running the TensorFlow Lite model inside it, so that you can get a smarter and faster response on the user experience. And that's the reason why we wanted to design our own ASIC, or the application-specific integrated circuit, or custom chip from scratch by Google engineers. That is called Edge GPU. So as you know, many people are depending on the GPUs from the major GPU vendors for both training and prediction of the machine learning models. But for the predictions, depending on the use cases, sometimes the GPU is too much, especially for the power consuming, because the tiny GPU can consume like 10 watts of the power. So we designed the ASICs, customized processors that only consumes 2 watts for very high performance the machine learning TensorFlow Lite prediction at 4 teraops operations per second. And by using HGPU, you can get the very, very fast inference speed. If you compare the performance with the other the prediction the ways such as the CPU prediction or GPU predictions, you can get like the 42 times faster inference speed compared with the CPU. And also, the TensorFlow team provided the optimized model for the image recognition for running on the HGPU called Efficient Net HGPU. Efficient Net is the state-of-the-art image recognition model right now, published from the Google research team, and that is now runs on the HGPU as well. So you can get the fastest and the highest the accuracy on the image recognition with the Edge AI. Let's take a look at another video for the Cora Edge devices demonstration. So as you can see, this is the miniature cars and the signals and the people. And as you can see, it's much faster than the ordinary CPU-based predictions. It's actually working over the 60 or 70 frame per second, so almost real-time recognition. So that you can apply this the HGPU with the TensorFlow-Lite model to the serious use cases such as the the autonomous driving, or some finding the defected part on the production on the factories or the belt conveyors. This is another interesting use cases of the detecting the direction of your heads in 3D the area, or on the direction of the eyes. And because it is using the HGPU, it was able to run the prediction over 50 frames per second. This is another interesting use case by combining HGPU with the ordinary x86 PC. And you can also use the Raspberry Pi for doing this. This is a smart shopping cart where it has the camera on the shopping cart, so that if the consumers, the shoppers are putting any vegetables or the items in the cart, instantly the system can provide the recommended those recipes for the cookings. And the AI processor is now sold with the platform called Coral. Coral is a new technology platform from Google, especially for this setting, providing the benefits of the HGPU for the developers. So this is already sold in globally. So if you go to any hardware resellers in the United States or Japan or APAC countries, you can easily find the HGPU products. And we provide different types of the HGPU devices, starting from the development board, which is a Linux, Raspberry Pi like Linux, the embedded Linux platform. So you can just use dev board for your evaluation purpose. Or another easy way to get started is to use the USB accelerator, as we have already seen on the AutoML use cases. And also for the serious use cases or embedded systems use cases, we provide this SOM or the PCIe accelerator card. And as I mentioned on the video, there's the Python SDK provided. So if you just to use the HGPU and TensorFlow-Lite model on top of it, it's very easy to use because there's a Python SDK already. And so you don't have to understand what's going on inside the TensorFlow-Lite and the compiler for the HGPU, etc. All you have to do is pass the TFlite model file to the SDK and pass the data like images or sound or any other data to the SDK, so that you can instantly get the prediction result within tens of milliseconds or few milliseconds. Okay, lastly, I'd like to introduce the AutoML technology called AutoML Tables. And in the suite of the AutoML products, we provide multiple products starting from Vision or the AutoML Video, which allows you to detect the object from the video or tracks a particular object in the video. And also there's another product called AutoML the Natural Language that allows you to train your own model for recognizing the text category for any specified languages. For example, if you have a bunch of the English text from the, for example, what's the use case? For example, if you are getting many users' voices or users' feedbacks from your products and services, maybe you can use the AutoML natural language for classifying those the users' inquiries or requests into a particular the categories. And also we have the AutoML translation, which allows you to customize the Google translation model for specified use cases. The downside of the published Google translation service is that you cannot customize the Google translation. For example, if you translate the user manuals for the IT systems, or if you want to translate the this captioning for the TV dramas or the movies, or if you want to translate any literatures, each the domains or use cases of translation should be customized, and but you cannot customize the Google translation. So you can use the automated translation for getting the customized the translation model. So those are the existing automated products. And the latest one is the AutoML tables, which I'll be talking about in detail. And the AutoML tables is an AutoML service for the table models or structured data. And this is not directly related to the mobile users or the embedded users because it doesn't work on the TensorFlow the platform. But many mobile developers are collecting all the logs or user activities on the maybe BigQuery or Google Cloud Storage or maybe Firebase, Fire data store. Then you may want to hire some data scientists for analyze your user activities with your mobile applications. In that case, maybe for some use cases, you can just use the AutoML tables instead of hiring the cutting edge data scientist, and press the training button. So it's possible you can get the intended result on the AutoML tables. So it's all about the structured data. For example, if you have the product table on your BigQuery or Firestore, maybe you may want to have some the problems or requirements where you want to predict on some suggested the product price, or you may want to classify users as a spam users or not, or premium users or not, things like that. So there's many requirements for the structured data. So that's the reason why we have applied the AutoML technology for the tabular data or structured data. And it tries to automate a major part of the machine learning the life cycle, starting from the defining the data schema, analyzing the data input, and training the model with the hyperparameter tuning, and the evaluation and deployment the model with the scalable platform. For example, if you use the AutoML tables, it tries to detect the data types of each attribute or column or feature, like whether it's a number, whether it's a timestamp, whether it's the categories or lists and things like that. And also, before pressing the training button, you may want to check out all the statistics or distribution of the training data. If it's imbalanced or not, or if there are any numbers of the missing values, how about the outliers? Those are the very important factors that affect the quality of the training data and also the result of the trained models. And by using the TensorFlow, by using the AutoML tables, you can easily visualize those the statistics. And also, the senior data scientist knows many different the models, starting from the linear models, logistic regression, or deep learning models, or the wide and deep models, which means the combination of the linear model and also the deep model. Or just like many other calculus, people may want to use the GBDT or the decision tree based models, like a random forest, or the many other models, blah, blah, blah. So there are tens of different models that could be applied to the many use cases. So the AutoML tables try to automate choosing the best models for you. So behind the scene, the cloud service tries to make ensembles of the different models by trying out the different models, like a deep model, neural network model, or GBDT or linear model, and does the bagging ensemble based on the multiple models, and provide it for you as the best result. What's the performance of the AutoML tables? So to test that, we have applied the AutoML tables for the actual competitions on the cargoes. That is called the medical price suggestion challenges. And this is the proper cargo competition. So there has been over 1,500 data scientist teams join this competition to train a model that predict the suggested pricing for each the product item sold on the Mercari selling app, with those features starting from the names and conditions, or shipping conditions, or the item description. And this is the graph of the performance from all the teams. There has been 1,500 teams joined this competition, and the vertical axis is for the error rate. So this is the left top, the team is the worst team, and the right bottom team is the best team. And AutoML Table's performance is just above the top 500 teams with the 12-hour training time. So it's not so bad. It's not the best, but it's not so bad. It's as good as the senior data scientists in the top 500 teams. And the cost is only about $300 with the 12 hours training. So it's just like spend $300 for hiring a senior data scientist. And you can press the training button many times because it's a crowd size. And everything runs in parallel. And lastly, I'd like to show some the use cases of the AutoML tables. That is from the GNP Seguros. GNP Seguros is one of the largest insurance company in South America. And they have been building their own, machine learning models and statistic models for the car insurance or the healthcare insurance and life insurances. And when they have applied the AutoML tables for detecting the healthcare fraud use cases, they were able to get the 20% or 30% the improvement with the compared with the existing machine learning model for finding the fraud use cases. And actually you can see on this slide, they are spending about $700 million US dollars every year for payment for the healthcare claims, and a minor part of that the healthcare payment is fraud use cases, and so that if you get the 20% or 30% improvement with the fraud use cases detector, then that means the AutoML tables can provide a benefit like with the millions of the dollars of the US dollar benefits to you just pressing by the training button. So that was the topics I wanted to cover. So if you're interested, please go to the TensorFlow, Coral, or AutoML Vision website so you can learn more. So that's it. Thank you.
So we have Hoi, Khan, and Kaz with us. And let me take the first question, which is for Hoi. This is a question from David. If we add an ML model to mobile apps, will it significantly increase the size of the app?
Yay, thank you for the question. That's a great question because actually some developers have run into this problem. As a piece of background information, Google Play supports a maximum of 100 megabyte of app sizes. And also your user don't really want to download that kind of large apps. So I think the first two things I would do is basically to try to reduce the machine learning kind of model. So even if the user can download it, it's a little bit of a hassle. So the two things I would do, one is try to see whether you can quantize your model. So instead of using a float, which is a 32-bit data structure to describe your model, I would try to use, say, an unsigned int, which is 8-bit. So instantly you cut your model by down to a quarter of the original size. So that's the first thing I would do. Second thing is, and this takes a little bit more expertise, and I don't know if Khan and Wei will run it through in a future more advanced session, is to basically say, hey, let's take out different layers or let's take out different nodes within your machine learning model. That can also reduce the size, but that takes, I think, more expertise. Alternatively, you can also, instead of reducing the size of your ML model, you can also serve it using a cloud infrastructure. And one of the ready-made API that we have in MLKit is called MLKit Custom Model, where you can upload your model to our server, and we'll serve it for free to your user. But do note that the maximum model size is about 20 megabytes. So if you have a 100 megabyte model, that would not help you. We actually had that question before from developers. So just to kind of sum up, first thing is reduce your model size, firstly. And then second, if you can't, then you can host it in the cloud.
Thank you so much, Hoi. Here we have the next question. Next question is from Pei Seng Tan, and it's here. Can you explain the difference between average precision and average recall in evaluating object detection algorithms? And is it the same with precision and recall in the image classification algorithms?
Yeah, that's a great question in terms of kind of putting into context what we just talked about. So in the case of high precision in object detection, what it means is you see a lot more objects. You see less objects in what is being detected. So if you point it, let's say at a chair, then it will just detect one chair. But on the other hand, if you have a high recall, then you can imagine that the algorithm might detect a chair, but in addition to that, it might also say, hey, the 4 legs that the chair have, maybe each of them look like a baseball bat or a cricket kind of bat. It might detect 5 objects, for the one chair. So that is basically the context that we put in. In terms of image classification, so high precision, again, it might kind of detect it only when it's really sure. So if you have a very noisy background, it might not classify things properly. Whereas high recall, you might have a kind of lower threshold for classification. But one thing to note with classification, and this is what I learned from the Hoi or not example, is if you're doing classification, make sure that you have a balanced data set. So if you have just apple and oranges, that's relatively simple. But if you say one object or not, that is really hard to do, because the or not is basically the entire universe. So you need to collect samples of all kinds of different objects. And that's where it kind of gets hard with kind of real-world kind of machine learning. And if you can control the input, this kind of problems become a lot easier.
Thank you so much. The next question is from Vijaya, and it's this. How can we add pitch to TTS so it will produce another characteristic sound? And how do we use another model like a tacotron to produce speech on Android instead of using a server?
So I'm afraid I'm not familiar with tacotron, so I would not be able to answer the second part of that question. But in terms of how you can get different TTS voices, the text-to-speech API in Android supports different kinds of voice, but it's not determined by pitch, but rather it's determined by kind of the language and the location and the and kind of maybe male or female. So one of the things that you can do is to is to call the TTS API and say action check TTS data. And one of them will be the available voices that you can, as an array, access for that particular language. And then from that, you can choose from one of the available voices and say, hey, can you please speak in this particular voice? So it's not done by pitch, it's done by available voices.
Thank you so much.
Yeah, I can add,
Sure.
I can answer the tacotron question. So tacotron has TensorFlow implementation, and what it can do is you can try to convert the tacotron model, TensorFlow model to TensorFlow Lite, and use it in a mobile app. We haven't tried that by ourselves, but if you try it and if you find any issues, feel free to raise the issues in the TensorFlow Lite, in the TensorFlow GitHub repository, and we'll try to address that.
Right. Thank you so much, Khan and Hoi. Moving to the next question. Does it have pre-installed languages support? Does it translate to Portuguese?
So I guess this question is related to ML Kit Translate. So by default, the answer is no. We do not have all the language pack kind of downloaded. Each one of them are it's not huge, but it's not very small either. So each one of them is like tens of megabytes. So we will only download it if your user need it. So one of the thing within MLKit Translate is to say, hey, which language pair do you need? And then as a developer, you can monitor whether the language pack has been downloaded. And if not, you can then download it as part of the flow or as part of the first use of that API.
All right. The next question is from Shashank, and it goes in. Can I use my own voice commands by using ML to create a password which can be used to log into the device in which I use that? And it works for only my voice, not anyone else's.
Yeah, so this one, I would say that it is not supported by ML Kit or the Android API that I talked about. So the Android API that I talked about is used for dictation. It is not used for what we call voice print. So this particular use case is not supported out of the box, but I think Khan have a fuller answer.
Yeah, so if you go to the TensorFlow Lite website, you will find that we have an examples showing you how to train a speech command model that can recognize like different words. So things of like the OK Google hot words, the samples that we have there, you can use it to train your own, say, hot word that you can use as a password. But I would like to point out that it is a very simple model, so it won't be secure enough for you to deploy in production and use it as a password. But it's a good place to get started and see what is the direction that you need to investigate more to build a production-ready solution.
Sorry, I smile a little bit because I think Khan just triggered like millions of Android systems around the world. So that's great. Yay. Yeah, and just to add to Kai Khan's point, the one kind of security, please kind of take care because rolling your own security is always risky. And then secondly, kind of the speech classification examples that we have is essentially say 10 keywords of that the user can say, up, down, left, right, etc. So it's the same kind of work that we're doing as image classification. So if you have, say, hey, this particular password phase and everything else, so it is again like the Hoy or not example where you go, hey, this is the one noise that we want to detect, and then the other case is everything else. That's an incredibly hard model to add because you need to add all kinds of background noises. You need to add kind of different people saying different phrases, maybe not even your password phrase. So yeah, so some of these kind of problems are maybe a little bit harder kind of than it looks in terms of kind of getting the correct sample and the data size.
Thank you so much. The next question is from Dhruv. The question is this: can I use model prepared through the Teachable Machine in Android Studio?
Yeah, I can take this question. So the Teachable Machine does provide TensorFlow Lite model for those who are not familiar with Teachable Machine. And that model doesn't have the necessary metadata to be parsed by Android Studio, but you still can use that TensorFlow Lite model with the TensorFlow Lite support library that Wei showed earlier in his tutorials. So feel free to try it out.
Right, thank you so much. The next question up we have from Amita. And the question is here: it's already implemented in phones using Google Assistant. What's new in there?
Okay, so I guess this is, again, kind of related to the voice recognition and text-to-speech. So I think those two may be quite different, or you can create a slightly different experience compared to the Google Assistant. So if you code for the Google Assistant, what it supports is, you can talk to it, and then it will fire off an action, and it will give you input, and your web app can essentially return an output. But what I've demonstrated is something that is of a building block to that kind of experience. So you can build something completely different. So for example, you might have an app with passages of content, and then you can just say, hey, tap here, and I can read it back to you. That's not something that you get kind of directly out of the box with the Google Assistant. You can basically bring some of those directly into your app. So you can do whatever you want with just kind of speech recognizer and text to speech, and you can combine them in whichever flow that you want and create something different.
Thank you so much. We'll take one more question for Hoi, and then we'll move to questions for Kaz. And then if we have some time left, we'll come back to Hoi. So Hoi, the next question is this. What's the difference between embedded ML kit to call TFlite and directly call TFlite model in Android?
So there are two ways to use TFlite with MLKit. So the first one is, as I described before, if you have a model you want us to host and you don't want to bundle it within your app, and you only download it when the user use it, then we have MLKit custom model, where you can upload your TFlite model, and you can use interpreter and wrapper in MLKit to get access to that model. The second way to use MLKit with TFlite is to join them together. So in terms of what we call, I guess, a very simple term, kind of like a pipeline, where, say, MLKit do the sum processing before handing it to your model. So maybe two examples. One is the example that I use in my talk, where you have object detection and tracking. So you point the camera at towards a scene, you pick out the object, and then you crop the image before sending it to your model. And what this do is it helps you kind of remove the background noise. And so you are detecting the object that the user actually want to focus on, rather than just the entire scene. So that's one way to do that. Another example that I also often highlight is related to natural language processing. So let's say you have your own version of Smart Reply, but one of the things that natural language processing doesn't do very well is, and I guess also human, is if you talk to it in a different language. So maybe the first thing that you want to do is to just say, hey, is that person speaking in English? Is that person speaking in Spanish or Chinese? And within MLKit, we have an API called Language ID. So you can just call that and pass it a string and say, hey, what language is this? And then only after it say, hey, it is one of your supported language, then you go process it using, say, your own TFlite model. So in that case, is basically the first stage is MLKit, and then the second stage is the TFlite. And if you're using it in that way, it doesn't really matter whether you call it within the MLKit custom model or kind of calling the TF interpreter directly. Both will be the same. So yeah, so you can use it either as a hosting service, MLKit, or alternatively put it into a pipeline, run MLKit first to validate your input, and then pass it on to your own TFlite model.
Thank you so much, Hoi. Now taking up the questions for Kaz. The first session is this. Is there any latency in training the model? How to know that and how to avoid that? This question is from Ari Manik.
Okay, I suppose this is a question for the AutoML, and I think it's not about training, but the prediction, because as we all know that training usually takes like hours for training any TensorFlow model. Even with the AutoML, it would take like 12 hours up to 24 hours. Usually, usually the training should be finished within 12 hours. So it's not latency, it's kind of, training time. So if it's the questions for the prediction latency, if you are doing the predictions at the cloud side, for example, the AutoML Vision allows you to do the prediction at the cloud side as well as the edge side, then cloud side prediction would take like 1 or 2 seconds, because you have to upload your image data or any data sent to the cloud. That takes time. And also the cloud predictions uses the larger models, like hundreds of megabytes of the model. So the easiest way to shorten the latency is to choose the edge side models. So as I have shown with the video demonstration video, you can download the model as the edge side TensorFlow Lite model that only contains like 7 megabytes instead of the hundreds of megabytes. And also you don't have to send the images to the cloud. So the overall latency is so much faster. For example, if you run the TensorFlow Lite model generated by the AutoML Visions running on the ML kit or the Android or iOS devices, I suppose even if you are not using any specialized hardware acceleration like a GPU or HGPU, even with the CPU, you would get much faster latency, such as like a 15 milliseconds or maybe 100 milliseconds. It's much faster than 2 seconds. So that would answer the question.
Thank you so much, Kaz. The next question we have is from Amin and goes up here. Do you have a tool for object detection providing bounding boxes on the cloud?
Yes, we have. So there's a couple of options for passing the annotation data for the object detection training data. And there's a UI on the AutoML Vision Edge, AutoML Vision, where you can use the UI for actually specifying, annotating the bounding box by yourself. And you can also choose to import the annotated data by using the external tool.
Right. So next one, I'm combining two questions from Sawan and Takarasan, and it's related to Coral. Where can I buy Coral? How does the Coral platform tie in with the industrial IoT?
Yeah, Coral are sold by the major the resellers such as the Adafruit or SparkFun. Those are the major resellers for the electronics parts. So you can just search with the keywords such as Coral reseller, so you can easily find those resellers. And the industrial IoT applications. As I mentioned, the Coral devices has been already sold and used by the actual production users, especially for the factories and industrial use cases. The customers we have in Japan is they are using the HGPU with the TensorFlow Lite model for finding the defective parts on the belt conveyors on the factories. So yeah, actually the major use cases is the manufacturing and the factory use cases.
Okay, the next question is from Fakrian, if I'm not wrong in pronouncing, and goes here. For the data that can be used as input, is it possible if I use some kind of stream data like sensor or trajectory?
Yeah, because this is I'm not sure this is questions for the TensorFlow Lite or maybe HGPU. But anyway, because HGPU can run the TensorFlow Lite model, so it's not limited to the image recognition model, and you can also apply the HGPU or TensorFlow Lite for doing some smart analytics on the time series or stream data. For example, I think it was 1 year ago, I have created one interesting demonstration where I have used the AutoML Vision and also HTPU for detecting the sound, not the visual object. And in that demo, I have used the audio spectrogram to convert the sound into the image data with the fast Fourier transformed the audio spectrogram, so that you can convert the sound features into image features that could be detected by the HTPU and also the AutoML Vision.
This question is from Pei Sang Tan. I think he's asking his third question. Does the AutoML table perform on time series data forecasting?
Yes, it does. And actually, it tries to automatically detect which ones is the timestamp column or timestamp features. And you can also manually specify this is the timestamp column, so that the whole training is designed for the aimed for the time series analytics. And AutoML tables can automatically split the training data into the training data and the test data. And once it detected its time series data analytics, then it tries to split the data based on the timestamps, like by training the model with the past data to predict the future data. So yeah, so in that way, it supports the time series analytics.
Thank you so much, Kaz. Thank you so much for answering the questions patiently. Last one up for Hoi. This is from Veena. I'm curious how ML can do so many models with less time consumed. Correct me if I'm wrong.
Yeah, so yeah, some of the demo that you've seen today is something that I would say maybe 5 to 10 years ago we thought we can never do, and part of it is, going back to what Khan said at the very beginning of this particular bootcamp, is that actually we're not using the device to do training for machine learning. We're purely using it to run. In a lot of cases, there's some minor exceptions, but in all the cases that we've run through today, they're all about essentially using a model that you have trained already. In addition to that, we have a lot of different techniques nowadays. So to highlight a couple, one of the things is when you compile your TFlite model, when you run the TF interpreter or the converter, it basically simplifies your model a lot. So when you look at the model structure before and after, some of it is changed a little bit to make it kind of run in a smoother way on a mobile device. Second is, a lot of new techniques. So, for example, quantization, where instead of using 32-bit numbers, we're now using 8-bit integers. That is also something that is relatively recent. Basically just a lot more research and hardware support. And here I would also like to highlight, the acceleration hardware that we have on Android, for example, with GPU, and also with newer phones, the neural processing unit, NPUs. One word of warning, if you do decide to use those accelerators, is that please do try your own particular model with a representative set of kind of phones that your user might run, because of some of the intricacies and ops that you might use in your model. That sometimes it actually run faster with just CPU, instead of running bits of the model in CPU and then transferring some of the processing into specialist hardware like GPU or NPU and then coming back to CPU again. So our best advice for those of you that are kind of looking for the more advanced option in terms of using accelerated hardware, then please do try them with your own particular model and see what happens, and then also can give us feedback on basically how we can do better with our GPU delegates and with our NN API delegates. Are there particular edge cases that we have not taken care of? This area is relatively new, so we're really looking forward to collaborating with developers on this.
So I'm taking the next question from Savan, and This question is, what is the minimum app size that we can have with an integrated ML model?
I think I can take this question. So the minimum here means, I think it literally means how large is the TensorFlow SDK plus the Firebase SDK that allows you to download the model from the cloud. So the idea is that the thing that you can download the TensorFlow model dynamically from the cloud, so that won't be count towards your app binary size, but it will need the inference engine, in this case, the TensorFlow SDK in your app when you publish it on App Store or Google Play. So the TFlite SDK size is, I don't remember the exact numbers, but it's a few hundred kilobytes, which is pretty small.
Thank you so much. The next question we have is for Hui. This is from Shashank. Can I use machine learning to make my interpreter to code and run a whole program by itself? Just I have to provide a little command by me. If yes, then how to use it?
So there are different ways kind of to build a kind of machine learning program on Android in particular. So you'll always need a little bit of code kind of to wrap your machine learning model. So you need the camera code or the code for getting access to a microphone or any kind of sensor. You need input in order to run your program. So there will always be those kind of wrapper. But this is an interesting question to ask in relation to Android 11, which is the version that will be coming out later on this year, because there is two ways to build a machine learning model. One is, and this is a slightly advanced topic that we are still kind of finding our feet on. So the first way is to have lots of little machine learning models, kind of one maybe running after the other and kind of work in unison. And the other way is to basically have a very large model with branching logic of if and while kind of statement embedded within the model. And starting with Android 11, we actually support the acceleration of both types. So for the first type, where you have lots of little models, we have new APIs which allow you to run them asynchronously, and then kind of all come back with kind of the result, and then you can then string together, or alternatively reserve a little space in your GPU or your NPU to run those models repeatedly. So those are for small models. And then on the other side, we have acceleration for branching kind of logic embedded within the model. But we're getting kind of which model should you choose. It really depends on the kind of use cases. And I have to say that these kind of scenarios are still fairly new, and our own kind of Google research is still kind of working around kind of which way is best. Build one monolithic model that you accelerate, or is it like building lots of smaller models and then string them together with kind of in native code? So expect some of these APIs or new APIs to come through on TensorFlow. So TensorFlow, I know that the Android team and the TensorFlow team is still working on basically implementing all these accelerated features on Android 11. So you'll hear more from us on this.
Thank you so much, Hoi. The next question is up for Khan. Can I use TFlite to train a model for recognizing people from low-resolution thermal images?
Yeah, so there's no pre-trained model for that use case, but a thermal image is typically just like a similar to any other image. What you need to do is you should check out the recognize handwritten digit code lab that we have on the Google Code Lab site, which teach you how to use Keras and TensorFlow to hand code a TensorFlow Lite model that can recognize a low resolution image. Another things that it might benefit you is that you come to our next bootcamp, which will exactly teach you about how to build custom machine learning model, and you will find out more about that use case there.
Thank you so much. Taking next question. The next question we have is from Azhari. The question goes here. Can we add our custom method in TFlite in mobile using C++ to improve performance?
So I'm not sure if I understand correctly, like what custom method means here. But TFlite does support C++. Oh, actually, it's like a C++ library and has C++ API, which also have a wrapper API for Android and iOS. So you always can use the TFlite C++ API directly to like get the most out of your TFlite model. It will be faster than doing that in Java, or especially Java, because it's it runs on the VM. Yeah, so we also will have C++ samples of TFlite coming soon, and feel free to check it out.
Yeah, and one thing to add is if the question, when they say custom method, if they mean custom ops, so in some very advanced kind of ML research, they may come up with new operations. Then in those cases, you would need to implement them kind of in TFlite and compile your own version of TFlite interpreter. And I think, Khan, you have done that before, right? And it is kind of maybe, yeah, of a slightly advanced kind of topic.
Thank you so much. And we will just take the last question of the day, since we are 2 minutes to go before we close off. So the last question here is from Avijit, and is, can custom LSTM-based models working on text data can be converted to TFlite format?
Yeah, so for LSTM models, we do support converting tf.keras.lstm ops into TFlite. So if you use that path, then your use case, your model is already supported on TFlite. But if you completely implement a custom LSTM model that is not using the Keras API, then you will need to implement your own TFlite operators to support that.